First of all, the only thing that we're testing, the only circuit we're testing is the cranking motor circuit. Battery, starter solenoid contacts, not the coil, starter motor itself, and all of the circuitry, including the ground return path, the connections, and everything that's not the battery, the contacts, or the starter motor. Okay, so it's the only part of the system that we're testing right now. And the reason we're doing this, obviously, is because we want to know if the starter has the horsepower to turn the engine, right? So what we're doing is we're using the starter as the load for the battery, which quite frankly, under normal circumstances, is going to be the biggest load the battery will ever see under normal circumstances. So you don't need to go out and spend $1,500 on some fancy schmancy load tester, computerized load tester. You can do this test with a voltmeter. So, you know, we're really not talking about anything amazingly complicated. But this tool, the Starter Buddy, does make it much simpler to do, especially if you're working solo, if you're field service, or if you one of a lot of guys out there who are independents. You don't have anybody to work with, and quite frankly, I'm not sure I want to trust anybody to crank the engine when I think I told them to do it and they thought I might have said go. You don't want to take those chances. So putting your hands in dangerous places with people you don't necessarily trust with their hands on the keys is a bad way to go about making a living. So what this tool does is it essentially does what I teach people to do in class, but it does it way simpler. Okay. The other thing is, and I want to repeat what I said, is that if you do the math on a simple circuit, 10 volts and 250 amps, you're talking about 0.04 ohms. And in the demo on the board, in the classroom, I use 0.47 ohms, which is roughly 10 times more resistance in that small resistor than is in the entire cranking circuit during normal crank. And any additional resistance is a problem. So your best money is always going to be on cables first, and batteries probably second, and then starter third. But the whole point of this Starter Buddy is that you never have to worry about that anymore if you do it right. And when this is all said and done, you're going to find out how simple it is to use this tool. Now, some people would say, well, I don't have time to set the test up, and it takes too much time to find the starter, and I'm not going to have a drill, and blah, blah, blah. Okay, well, yeah, that takes a little time, but so does changing a starter unnecessarily, and so does changing batteries unnecessarily. You can decide whether or not the 15 or 20 minutes it might take you to set up the test that's going to take less than 3 seconds is worth your time and effort to avoid having to spend 2 or 3 or more hours pulling a starter that you have to get to anyway to pull it. So you might as well get to it to test it. Or batteries, when quite frankly, changing batteries can be expensive. So if you're in a fleet, or if you're somebody who doesn't want to insult somebody by charging them way too much money and come off looking like an idiot, because I know you're going to say, well, he's going to need those anyway. Yeah, he was going to need those batteries. He's going to need that anyway. So we changed it out. Yeah, that's weak. That's just weak. Okay. So let's try to avoid that, and let's avoid it by being precise. And we can be very precise by using this Starter Buddy to make sure that the right part is either repaired or replaced, so that the cranking diagnosis will be exact and perfect every time. So, all right, here's the classroom mock-up that I built, and it's fairly straightforward. By now you guys may be familiar with this cardboard and foil tape method that I'm using. What I have here is a battery, and it's about 12 point something. And I've got the starter motor here, which is a simulated, obviously, but it's a pretty good simulation. It's a window motor, and I just got it yesterday, in fact, and pulled one out that I had in and put this one in. So this is a relay that's playing the role of the starter solenoid. Okay, so this is going to be the whole starter unit here, right here. All of this. This is going to be, well, sorry, here's the solenoid on top of the starter. Here's the starter. Here's the gear drive. You know, whatever. Okay, good simulation. So when I push the start button, what the start button is going to do is going to turn on this relay by energizing the coil. when the coil energizes, then the contacts close, the motor should run. Well, the motor is going directly, the battery is going directly to the starter motor like it does. And then this would be coming off to the fuse panel, and this is the fuse here, and going to the starter button, and then this is going to be the load. So this is a pretty common system. I could have added a third leg in here, but it wasn't much point, right? Okay, now, here's what we're going to do. The components here on the, the connectors here on the starter buddy are really pretty good. Now, they're not perfect. I'm not going to lie to you, they're not perfect. Okay, but I mean, quite frankly, there are a lot of different setups for a lot of different batteries. These are really, really high quality clips. But to be honest with you, your battery may still not really be, these may not be perfect for your battery. So that you need to be on the posts, okay? And you have to be on the studs, and you have to be on the studs, okay? And the reason is, very simply, we don't want any corrosion in the cable to show up as a voltage on the starter. And we don't want any corrosion on the cables to show up as a voltage in the battery. So we need to isolate this, and this, the ground path. And the ground, and the cables need to be, they need to be isolated so that when you're testing cables, you're really testing cables, okay? Can't overstress that. That's what's going to take some time to set up. And I think the important thing is that you take the time you need to do what you have to do to make the test work by setting the test up properly, by making sure you're as close as possible to the source and as close as possible to the load with nothing in between. Okay, very, very, very important. All right, not always easy to do, but it's important, and it's very important. And even if it takes you 30 minutes to set it up and you find out it's the cables, that's better than changing a starter and changing a batteries to find out that it's the cables. Okay, so what happens is when you plug the I put little doohickeys in here so I could attach these. I wanted to use the real clips. When you attach the starter buddy, what it does is it starts up. Okay, now you notice showing the battery is at 13 and the starter's at 0. Well, I don't have the starter hooked up. Well, what we said is that whatever is here should be here, and whatever is here should be here. So I'm looking for the exact same number. If the numbers aren't the same, there's something weird going on. Okay, so you clip the starter cables, and bingo, now we have the same numbers. All right, now I've got a corroded fault in here, but I was going to do it one way and I'm going to do it a different way. I honestly don't know which way this switch is, and this switch turns this fault on and off. So I'm going to do this. And I'm not sure, I don't know where it is. Nothing up my sleeves. I have no idea whether this is in the circuit or not. Okay, I don't. But let me point out something. It's only 1/2 ohm, which is still 10 times more resistance than the circuit in the starting circuit has normally. Okay? So this is very simple. You got it all hooked up, and you just go, bingo, start test. And it says crank engine. Okay? Now watch the countdown. Okay, now, first things first. Do you think a 12-volt starter or motor is going to work normally if it's only getting 10.4 volts? Well, the answer is no. But the battery was holding 12.3 under load, so the battery was giving us plenty of voltage. But it's only using it's only getting and using 10.4. Well, I would never expect a starter to run on inadequate voltage. So the starter, in this case, is not going to be replaced because it ain't working right, because it ain't getting enough energy. All right? So then we just hit the test info button. Bingo. Positive cable drop. Nothing. 12 point something. I don't know what it was. We'll find out what it is. Oh, 1.99 volts. Well, there's my 1.99 volt fault right there. Okay? So not only is it telling me that there's a problem in the cable, it's telling me that it's in the negative cable. That's pretty damn cool, okay? And this is 150 bucks. Okay. So let's go fix it. I'm gonna scrub, clean, whatever. Okay, I believe in silicone spray, by the way. So now it's fixed because I magically fixed it, right? Now watch. Let's retest it. Well, battery and starter, that tells me that I've got the same voltage at both places. That's a good thing. I don't have an open. If I had an open, I wouldn't be reading that, and I'll show you that in a second. Okay, so if I have everything set up and I've cleaned it, then what I expect is for this number and this number to be pretty doggone close, and for both of these numbers to be pretty close to 0. So let's see what happens. Now, 12.2 and 11.9. Okay? Still nothing in the positive cable. But my drop is down to 0.33 volts in the ground side. Okay? It's important. All right, now watch. Notice that we've got a battery voltage here because we're reading the battery voltage. We've got a starter voltage because we should be reading the starter voltage. Okay? And those two numbers should be the same, and these two numbers should be the same, so these two numbers should be the same. All right. Well, watch what happens if I have an open ground. Okay. I still have full starter voltage, so I'm like, okay, well, then I can start the test, right? So I start the test, and it doesn't work. Well, wait a minute. Why did I have? Wait a minute. Oh, well, it's not cranking because nothing's happening because I don't have a complete circuit, so the tool can't see the circuit. Well, as soon as I fix the circuit, it starts working again. Okay? So there's that. Now, watch what happens if I open the positive. Well, see, I have nothing at the starter. The starter has no volt. I've got a good ground, but I've got no positive. So right there, the tool also shows you whether you have an open cranking positive or an open cranking negative, all right? Because if it's an open positive, we don't get voltage and the starter doesn't turn. So we have no voltage to positive, open positive. If we open the ground, we still have voltage because we're still reading voltage. Okay? Okay, but we don't have a ground. All right, so we try to run the test and nothing happens. But the fact that we have, the fact that we have a the fact that we have presence of voltage tells me that it's an open ground. Sorry, a little brain fart there. So there's a lot of information that this tool will give you for not a lot of money and for not a lot of time in an environment where we make a lot of bad decisions and we replace a lot of these and replace a lot of these when we really should be just cleaning these. Okay? So that's the classroom. That's how it works. As long as it's connected properly, it's going to work. And it's very accurate.